Okay, so it is September 22nd, 2020, and we're going to continue learning Tinkercad. So what you're going to want to do is get logged into your Tinkercad, um, and you're going to click Learn in the upper right. So once you get logged in, you're going to click Learn in the upper right, and then you're going to click on Lessons right there. And you don't have to do this right now while I'm presenting it. You can watch this and then go back later. And actually, and I'm sorry, I meant projects. You're going to click on projects and then introduction to primitive shapes. So let's go along with me on that. Here's the description. It says taking an idea from your mind to the real world. Can is an exciting adventure. Okay. In Tinkercad, this begins with a new design. In the new design, simple primitive shapes can be combined in different ways to build more complex shapes. In this project, you will explore primitive 3D shapes like boxes, tubes, and cylinders, and learn to identify those shapes in a larger design. So, introduction to 3D primitive shapes. We'll click on it to start it, and it's going to open up Tinkercad for us. Okay. Introduction to 3D primitive shapes. In this lesson, you will explore primitive 3D shapes like boxes, tubes, and cylinders, and learn to identify those shapes in larger objects. Welcome to the world of design. Look around you for a moment. Look at the chair you're sitting in, the desk you work at, or the school that you're in, or at home, right? Or in the vehicle that brought you to school. All of those things started out as designs and are now beginning the journey. Now you're beginning the journey to learn how to design and make things of your own. The starting point of 3D designs is a primitive shape. Primitive shape. These shapes can be added, subtracted, and combined with one another to build just about anything. The actions of adding, subtracting, or combining primitive shapes is called a Boolean operation. Here are some common 3D primitive shapes: cube, cylinder, tube, sphere, torus, and a cone. Let's look at those a little closer. This is a cube. That's a cylinder. That's a tube, right? There's a sphere. This is a shape you may not have known what it was called. It's called a torus. I mean, if you call it a donut, I'll know what you mean, but it's technically the primitive is named torus. And then that's a cone. All right. These are all three-dimensional polygons. All right. Or three-dimensional solid shapes. How many cubes or boxes? The exciting thing about design, other than making your own ideas real, is there are many different ways to combine shapes to make more complex things like this chair. Since there are many ways to design, there is no right way to do it. It's up to you, the designer, to figure out the best shapes to use, the best way to arrange the shapes, and the best order to group the shapes to create the shape you are looking for. See if you can count the number of cubes or boxes used to build the chair below. Well, the thing is that we know that the cubes, it doesn't have to be, a cube is the same size, all three dimensions are the same, right? But so they really, I think what they mean are rectangular prisms. So I don't know. I would say 1, 2, 3, 4, 5, 6, maybe. Let's see. Was it 5? Was it 6? See, was it 5? One, two, three, four, and then five. Oh, see what they did there? They cut out of a cube. Was it five? Was it six? Ah, see, that's what I counted. I counted each one of those. And then was it 240 Minecraft blocks? Yeah, see, it could have been, I guess. All of the above answers and many more are correct. It all depends on the materials you have and your specific needs. Each of these groups, when combined into a single object, make the same chair shape. So you could have done it in all those different ways and got the same exact chair shape. Locate the primitive shapes. It's time. This time, let's take a look at something a bit more complex. Below is a rocket. Uh, you learn how to make in the Build Your Own Space Station Tinkercad project. Can you identify the primitive shapes that make up the rocket? Have a look. Take your time. Well, I definitely see a sphere there. And it looks like these might be cylinders. And then down here, this is one you might not recognize. There's some cones in there. All right, so let's see. Can you find the sphere shape or shapes? Can you find the cylinder shape or shapes? Can you find the cone shape? Think you found them all? Continue to the next step to find out. Ooh. Aha, look at that. They color coded it. See the orange? Those are spheres. The purple, those are cones. It was two cone, one cone and then one upside down on top of it. And then the blue are the spheres, and there's spheres at the top and bottom of all those cylinders, and then one at the top. Yeah. Does this view help? Ah, you can see now they're all just smushed together and combined. Okay. Continue to the next step. At this point, you may think it's a lot of fun or a lot of hard work. Perhaps both. There is no question designing things can be a challenge. It takes a lot of practice. But when you learn how to turn your ideas into something real, the possibilities are endless. Who knows? Someday you may design a car. You may be a car designer, an architect, an interior designer, or even a movie maker. Check out this video to see how 3D designs are used in the making of the movie Star Wars: The Force Awakens. Ooh. Now let's take a look at that. It is 3D. It's amazing. Wow. There's like nothing there. They added everything. That whole building. So definitely the robots, some of them are practical, like that. That means you can see the green little arm thing is holding it and controlling it. But they add stuff to it that is not there. The 3D modeling, like his little arm that pops out. Oh, wow. This takes thousands of hours. This takes people stuff that people do every day, all day. This 3D modeling right here is so amazing. And just like in Tinkercad, when you guys create a model, you can then swing the view around. You can move it around and stuff. And so then re- they can move the camera around in their fake world and record, a video of it showing, telling the story, showing whatever action they want to show. But they have to basically make all the 3D stuff first. So that then the filmmaker can decide, oh, I want to see the ship fly through it in this weird way or whatever. Look at that. Oh my goodness. You see all those pieces? Every single one of those pieces was like 3D modeled and put in place. So much of that stuff you don't even see, but it's there because it's functional for the process of filmmaking. All right, guys. I think that's enough of that video. That's pretty freaking awesome. I wish I was talented enough to do that. I am, but it would just take a lot of work, right? A lot of hard work and learning, and you'd really have to dedicate a good amount of time to it. All right. So let's continue to the next step. Congratulations, you have completed this project. All right. So guys, this was just a project talking about these primitives and how they make up more complex shapes. So now that we're done, I'll click done, and then I'm going to go back to Tinkercad, the main window. I'll click on learn, and then I want to go to lessons. There we go. So let's do a lesson, or you can do this later. The chess pawn. I'm going to restart the project. Okay. And so the chess pawn, if you've ever played a chess game, or if you've ever done anything where any games that have game pieces like Monopoly or something, somebody had to model them. Somebody had to do a 3D render of them first, probably. So let's go ahead and do this one. It says, in this lesson, you will learn to design a traditional chess pawn. Let's get started. So it says we need a shape to get started with. Okay, so we'll grab this cylinder. And if you really want to make sure you do it exactly, use your views and your little arrow keys. And that way you can really make sure you put the thing where it goes. Also, when you do cylinders, notice the number of sides. Always crank it up to the top the most, because then it'll be the smoothest possible shape. Okay. All right, so then I'll click next. It says scale the height to 3 millimeters. So the height, it's already at 20, so I'll put 3 here and push enter. All right. Next. Okay, drag a work plane to the top of the cylinder. Now, this is something that I haven't really shown you before, but you have these right here. It says work plane. That will allow you to change. Notice like where you're working at. So notice that it changed like where I'm working. Anyway, it's helpful to make sure that you have stuff you're dropping stuff in the right spot. All right, so now let's drag this new shape. It wants us to put a cone there. Did I get it? Not quite. Darn it. Okay. There we go. And then the same thing, the number of sides. If you want to make it smooth, do more sides. Okay. Click next. It says scale the shape to shorter to a height of 11. So I'm going to click this top box right here. Look where it says 20. I'll change it to 11. Push enter. Click next. It says drag a sphere shape to the work plane. Okay. Sphere shape. And see what's happening is because I put that work plane, that orange work plane, because I put that there, it's going to drop the sphere to line up with that work plane. Otherwise, it would be, I would have to keep raising it up and making sure that it was at the right height and all that. Hey, there we go. All right. So now what does it tell me to do? It's going to tell me to squish it. Okay, so scale the sphere to a diameter of 18 millimeters. Let me show you how to scale a little bit easier. So I have my sphere selected. I'm going to click and drag, but if I just click and drag, I can get this really weird, smushy, sphere. If I want it to stay, I'm going to undo, right? If I want it to stay as a sphere, as a perfect sphere, I can hold down the shift key. When I hold down the shift key, it's going to scale the radius of the sphere and keep it as a sphere. Okay, so it told me it wants me to take it down to 18 millimeters. 18. There we go. Now I'm probably going to need to adjust. Yeah, I'll just push my arrow key. Then top. Yeah, up. There we go. And then it says squish it shorter to 5 millimeters. Okay, so it wants me to squish it. So I'll grab this right here and I'll put in 5. Enter. Ha! Get that little squishy little. And like you could have done this. We could have done this with a torus, but it wanted us to use a sphere, so that's fine. Okay, drag the cone shape to the work plane. Okay, it's telling us to put it right here, but just because we're going to work with it. All right, I did. Scale it to a smaller diameter of 14 millimeter diameter. Okay, so I'm going to put 14 here, and also 14 here. There we go. I'm going to move it. There we go. To where it goes. And then it's going to say scale to height of 28. I did that in reverse. I'm sorry. But then here's the height, 28. There we go. Boom. Again, I'm going to make sure it has 64 sides so that it's smoother on the outside. Yeah, better. All right, let's see what it says to do next. Okay. Move the cone to the target orange area. Okay. Okay, and then it's going to say lift the cone 3 millimeters off the work plane. Okay, right here, I can click that. And once you start dragging, you can actually click in this little box here and type in the amount that you want to raise it, and then push enter, and then it'll go exactly that. I'll click next, drag another cone. All right. And then I always make sure the sides are cranked up, so make it nice and smooth. Okay. Scale it to a diameter of 12 and scale it to a taller height of 19. So I'm actually going to hold down shift to do it like that. And then I'm going to click this box and put in 19. Sure. And then we'll line it up with where it wants it, just to make sure. Yeah, it's exactly the size and shape it wanted. I'll click next. Okay, rotate it 180 degrees. Okay, so I can click and drag like that. And remember, it'll snap if I stay inside. If I go outside, I get really granular. There we go. 180. And if, for instance, you're doing this, you're dragging it. Let's say that you're dragging it like this, and you're like, Oh no. Okay, if you click in the box, you can type in the 180 that you want. Okay. So like that, 180. All right, and it says move it to the targeted area. I'm going to change to the top view. Use my arrow keys. Okay, and then wants it to move it up, so I'm going to have to use that cone. And there we go. All right. All right. All right. Okay, drag a work plane right there. Okay, so I'm going to drag this work plane. Hey, come on now. Oh. And it's saying like right there. All right. Notice now the work plane is right there. So anything I bring in will drop it right on that plane. So it's nice because if I had brought a sphere in, earlier, it would have put it way down there. So anyway, let me click home so I can get back. There you go. I'll zoom in a little bit. All right, click next. It says drag a sphere shape to the work plane. Oh, I just did that. All right, there we go. And then scale the sphere to 8 by 8 by 8. Hold down Shift. Come on now. 8 by 8 by 8. There we go. There we go. I think that's where it wants it. Okay, drag the work plane to the original location of the work plane. Okay, so it means to just grab one of these, just put it there. And now we're back. All right, let's click next to select all the shapes. So I can do that, or I could do Control A. Control A is select all, by the way. Align the shapes in the middle. Yeah, they are all aligned. Click the Align button on the menu. Where's the Align? Oh, here it is. Align. Well, it looks like they're aligned. I wonder if they're off just a little bit, will it, and I select everything, and I click Align. Does it do it? No, it doesn't do it.
You have to click the button to align it.
Oh, okay. So if I click L.
You see the little dots that are at the bottom when you press align?
Yep.
You have to press those to align it.
Gotcha. Got it. So you can align it in different ways. So like you can align them all so they line up with that side, or all so they line up in the center, and then the center. You could align them so they all line up in the center like that. Of course, that's not what I want. So I'll click undo. Very cool. All right. I do not really use the align tool, so that's great. Thank you for telling me that. All right. So they're all aligned. And then I want to group them. So again, you can do Control A, and then you can do Control G, will group, and then now it's one piece. Or you could have just, instead of Control A, you can drag the select box, and then click the group button right here. Congratulations, there's the chess piece. So just like we did in that first project where we saw that things are made of different, different primitives, you can see here this thing is made out of a cylinder, a cone, a cone, a cone, a sphere, and a smooshed sphere. So there you go. All right, guys, I want you to do this one lesson on your own. So I want you to be able to make your own chess piece. If you want to make it a little bit different, that's fine. But remember, you're going to get to these by logging into Tinkercad. You're going to go to Learn, and then Projects is where we learned about the 3D or the primitive shapes, intro to 3D primitive shapes. And then lessons was where we did the chess pawn. And there's so many different lessons. You can say, see all lessons. It gets really advanced. So it gets really, really, really advanced. Okay. So we'll just start with the chess pawn. I thought that was a great example of how you have a more complex shape. And you can kind of see that the different primitives that are in it. But, then you get to actually do it yourself. All right, that's all I have for the recording. So I'm going to go ahead and stop the recording, and we'll go ahead and talk about what you're going to do for the rest of class.